Today, we're going to crack open one of the most important ideas in all of modern technology, object-oriented programming. And to do that, we're going to use one of the most famous programming languages on the planet, Java, as our guide to see how it all clicks together. All right, let's jump right in. So, to get started, we really need to ask a huge question. Think about it. Every single app on your phone, every website you go to, it's all this massively complex software. And that creates a pretty big challenge for the people who actually have to build all that stuff.
Seriously, how do you do it? Imagine trying to build a skyscraper by just handing the construction crew one single gigantic list of instructions. It would be total chaos, right? Well, that's kind of the problem early programmers were facing. As their programs got bigger and bigger, the code just became this tangled, unmanageable mess that was almost impossible to fix or update. They needed a whole new way of thinking.
And this was the big aha moment, the breakthrough. Instead of just writing one long recipe, programmers started to think in terms of, well, things or objects. Self-contained little units, each with its own job and its own information, that could all talk to each other. And this really elegant solution has a name.
This is object-oriented programming, or just OOP for short. It's really just a powerful way to bring order to all that potential chaos. You can think of it like creating digital blueprints for things in the real world, like a user or a product or even a bank account. And then you build your software using these smart little self-contained parts. And this whole idea is built on 4 key principles.
So, how do you actually build this organized digital world? Well, you follow 4 main rules, and people in the know often call these the 4 pillars of OOP. Let's break them down one by one.
The first pillar is abstraction, and this one is all about simplicity. Think about it. When you're driving a car, you look at the dashboard. You see your speed, you see how much gas you have. You don't need to see the thousands of tiny, complicated parts working together inside the engine. Abstraction in programming is the exact same idea. It hides all the messy, complex stuff on the inside and just shows you the simple controls you need to get the job done.
Next up, we've got encapsulation. The easiest way to think about this is like a little medicine capsule. It holds all the important stuff together in one neat package, and it protects what's inside from everything else. That's exactly what encapsulation does for code. It bundles an object's data and all the code that works with that data into one single protected unit. Our third pillar is inheritance, and honestly, this one is a huge time saver. Let's say you've already designed a blueprint for a generic vehicle. It has wheels, it has an engine. Well, now if you want to create a car or a truck, you don't have to start over from scratch. They can just inherit all the basic stuff from vehicle, and then you only have to add the new features that make a car or a truck. It's all about reusing your work. And our final pillar has a bit of a fancy name, polymorphism. But don't let that fool you, the idea is actually pretty simple. The name just means many forms. Think about an action like start engine. The way a car starts its engine is totally different from how a boat does it or how a jet plane does it. Polymorphism is just this cool principle that lets us use one single command, like start engine, and have it do the right thing, depending on what object you're talking to. Okay, so we have this powerful idea, OOP. But, ideas are one thing. You need tools to actually make them real. And back in the 1990s, a team led by a guy named James Gosling created what was basically the perfect language to bring these ideas to everybody, a language that was built on the principles of OOP from the ground up. And this was Java's big, revolutionary promise. See, before Java came along, you usually had to write completely different versions of your program for different computers. It was a huge pain. Java was designed to fix that. The goal was simple. Write your code one single time, and it should just work, flawlessly, on any machine, anywhere in the world. So what gave Java its superpowers? Well, it really boils down to a few key things. First, it's object-oriented to its core. It lives and breathes those 4 pillars we just talked about. Second, it's what we call architecture neutral, which is just the fancy way of saying run anywhere. And third, it's robust, meaning it's built to be super reliable and to avoid a lot of common programming mistakes. But how does it actually do that run anywhere magic? The secret sauce behind that run anywhere promise is this 3-part environment. Think of it like a set of nested boxes. The biggest outer box is the JDK, the Java Development Kit. That has all the tools you need to build the program. The box inside that is the JRE, the Java Runtime Environment, which has all the stuff you need to run the program. And then, at the very, very center is the JVM, the Java Virtual Machine. The JVM is the real magician here. It's like a universal translator that takes the Java code and makes it work on any specific computer, whether that's a Mac, a PC, or something else entirely.
So we get the big ideas, we get the tool. Now let's look at how Java actually puts all this OOPS stuff into practice with two of the most basic building blocks you'll ever see.
The first, and maybe the most important idea, is the class. Now, a class isn't the actual thing itself. It's the blueprint. It's the design document. A class defines what a certain kind of object is supposed to look like and what it's supposed to be able to do. So, for example, you could create a house class that says all houses must have a color and a certain number of rooms.
Okay, so if the class is the blueprint, what's the actual house that you can live in? Well, that is the object. The object is the real, tangible thing that you create from the blueprint. You can use that one house class, that one blueprint, to create a ton of different object instances. You know, a blue house with 3 rooms, a green house with 5 rooms, a red one with 10 rooms. Each one is a totally unique object, but they all started from and follow the rules of that original class.
Let's make this super concrete. Imagine we want our program to work with boxes. So, step 1, we define a box class, our blueprint. We say every single box must have a width, a height, and a depth. Step 2, we create an actual object from that blueprint, and we'll call our object MyBox. Step 3, we give our specific MyBox its own dimensions. Let's say 10, 20, and 15. And finally, step 4, we can just ask MyBox to calculate its own volume. It already knows how, because that ability was part of the original blueprint. That's OOP in a nutshell. And of course, to define properties like width and height in our blueprints, we need some really basic materials to build with. In programming, these are called data types. They're the absolute fundamentals, things like numbers, letters, and simple true or false values. These are the little Lego bricks we use to build up all the properties inside our classes.
Okay, I know we've gotten a little technical here, from the big pillars all the way down to the building blocks, but let's zoom back out for a second and just talk about why this is so incredibly important in our everyday lives.
So why does all this matter? Here's the bottom line. This way of thinking, of organizing code into these logical, reusable objects, it's what makes the software you use every single day possible. It allows huge teams of people to work together on incredibly complicated apps without the whole thing just falling apart. It's the secret organizational structure behind almost everything you do on a screen.
So I'll leave you with this final thought. The next time you open an app or send a message or check your bank account, just for a second, try to picture that hidden world of objects working behind the scenes. A user object, a message object, a transaction object, all of them talking to each other, working together to make your digital life happen. Pretty cool when you think about it, right?